Good afternoon, everyone. Thank you for joining us. I'm Steve.
And I'm Scott.
Together, we're Backyard Musing, the Science Technology Channel.
Yeah, we're talking space today. This is kind of this afternoon. This is cool.
So, if you've watched the, I think it's Wall-E, the movie Wall. Is it Wall-E? Eva? Yeah. Where by and large is the big corporation and humans have left Earth. There's all this space junk around Earth, right? The planet in orbit. So that's the story. It's an opportunity. Experts warn that satellite launches and discarded spacecraft are creating an unsustainable burden on both Earth and orbit. They advocate for a circular space economy built on reusable materials, better design, debris recovery, and advanced digital tools. In a paper published today, December 1st, 2025, in the journal Chem Circularity, a team of sustainability and space researchers explores how the familiar ideas of reducing, reusing, and recycling, that's the 3 R's, reading, writing, arithmetic, could be incorporated into satellites and spacecraft from early design and manufacturing through in-orbit repair and end-of-life repurposing. Would you like to know more?
Okay, so this stuff's floating around. It's not on land. It's floating around in the atmosphere.
Yeah.
Okay. Wow. As space activity accelerates from mega constellations of satellites to future lunar and Mars missions, we must make sure, this is a quote, by the way, we must make sure exploration doesn't repeat the mistakes made on Earth, says senior author and chemical engineer Jin Xuan of the of the University of Surrey. A truly sustainable space future starts with technologies, materials, and systems working together. Unquote.
Oh, in harmony. Okay, so I'm wondering, how are they going to get this? Are they going to use a big spacecraft vacuum sucker that'll just like kind of vacuum everything up? Are they going to use nets, or
well, this stuff's in orbit. It's in orbit, right?
Yeah, it's in orbit. So magnets?
I don't know. So they're gonna have to either be faster than this thing, whatever they're trying to recover, or have a long arm like a crane or a grabber or something to be able to catch up to it and grab it.
See, that's inefficient, though. I would think like a net.
You mentioned a magnet. Yeah. That's a good idea.
Primary sources of space debris include fragmentation events, 65%, such as collisions, explosions from residual propellant, and spontaneous disintegration. That's a new one. I'd love to have that power. Decommissioned spacecraft and rocket bodies, 30%, and mission-related objects, 5%, unintentionally or deliberately released during operations. The rise in fragmentation has triggered a self-reinforcing cycle of collisions, posing escalating risks to orbital sustainability. We also did a story on this too, that detonating a nuclear device in the atmosphere or low orbit would create something with the debris. We did a story on that, Scott.
Okay. The environmental footprint does not end once a mission is complete. When satellites and spacecraft are retired, even more material is effectively thrown away because these systems are seldom recycled or reused. Instead, many satellites are shifted into so-called graveyard orbits, or remain as pieces of orbital debris that can disrupt or damage active satellites. I need to think about this kind of stuff.
According to the authors, this pattern is not viable in the long run, particularly as private spaceflight, and commercial launches rapidly increase. They argue that a move toward a circular space economy, where materials and systems are designed for reuse, repair, and recycling, is essential to protect the long-term future of the space sector. And they point to precedents in personal electronics and the automotive industry as valuable sources of guidance. Yep.
Another quote here. Our motivation was to bring the conversation about, circularity into the space domain, where it's long overdue. This is according to Juan that we talked about earlier. Again, going on with the quote, circular economy thinking is transforming materials and manufacturing on Earth, but it's rarely applied to satellites, rockets, or space habitats. So it's like if it's up in space, it's forgotten. We don't need to worry about it.
Yeah.
So too bad.
The researchers suggest that building a circular space economy begins with the familiar 3 R's: reading, writing, and arithmetic. No, it's
Okay.
reduce, reuse, and recycle, the authors say. To cut waste, they recommend that spacecraft and satellites be designed to be more durable and easier to repair. Wouldn't we all love that? They also
Yeah.
propose that space stations be reimagined as multi-purpose hubs that support refueling, in orbit repair of visiting spacecraft, even manufacturing new satellite components, which could decrease the number of launches required. And let's call them a star base. How about that?
Yeah. Who was the guy that did the Star Wars? What was his name?
The star base? That was
No, no,
Kirk. Captain
no. The
Kirk.
guy that did Star Wars, that came up with Star Wars. That was his. It was his idea. What was his name?
Oh, that's the Death Star.
Well, no, but the whole Star Wars,
Yeah,
process.
the director,
Yeah. Well,
concept.
anyway, they need to
George
get this guy.
Lucas. George
Yeah, George
Lucas.
Lucas. Yeah, they need to get this guy on board because they have that kind of stuff, right? They reuse stuff. They have those little sand people that were going
Yeah,
around and
Jawas. Yeah,
scavenging stuff, and yeah. So anyway, to make reuse and recycling of spacecraft and space stations practical, the space sector would also need better ways to bring hardware back safely. The authors highlight, kind of like SpaceX, right? They're not leaving this stuff up there. The authors highlight technologies such as parachutes and airbags that enable soft landings, while cautioning that any reused parts must undergo strict safety checks, since spacecraft and satellites experience severe wear and stress in the space environment.
the team also calls for more active recovery of orbital debris, for example, by deploying nets or robotic arms to capture and retrieve discarded objects. This approach would make it possible to recycle their materials. It would also reduce the likelihood of collisions that generate even more debris.
Data analysis and digital tools, including AI systems, are identical as key enablers of more sustainable space operations, the author says or say. For instance, analyzing data generated by spacecraft could guide better design choices and reduce waste. In addition, computer simulations could take the place of some expensive, resource intensive physical tests, and AI could help spacecraft and satellites avoid collisions with existing debris. Okay.
Because a circular space economy would change how the entire sector functions, the authors emphasize that the problem cannot be solved by focusing on isolated parts or single technologies. Instead, they argue that the space community must examine the whole system at once, from materials and manufacturing to in-orbit operations and retirement. Retirement of the spacecraft or the satellites.
Okay, well, this is obviously a different way of looking at things for these space guys, but I would think that that's another person that get in on this thing would be Elon.
Yeah, just you start a company to specifically do this. You gather it, you melt down the metal, and you resell it to Elon or NASA or whatever, so they can make more boosters.
Yep. So I'm sure if they can think it, they can ink it. It can be done. So, all right,
folks.
Great story.
Thanks for joining us. We'll catch you tomorrow.
We'll take care. Talk to you tomorrow. Thanks.